Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve this problem from chapter 13. The problem says that the collar has a mass of 2 kg and travels along the smooth horizontal rod defined by the equiangular spiral r equals to e to the power theta m, where theta is in radian. And it is said that determine the tangential force F and the normal force N acting on the collar when theta equals to 45 degree. If the force F maintains a constant angular motion of theta dot equals to 2 radian per second. So we need to note down that this collar is moving in a horizontal rod. So the weight is going to act into the page, right, or into the screen. So now we are going to solve this problem using the cylindrical coordinates. So this will be my positive radial direction, and in the increasing theta direction we will have the positive theta direction. This will be my positive theta direction, and in the problem statement it is also said that determine the tangential force F. So this force F is going to act along the tangent, and that force will be tangent to this path at this particular instant. So let me draw the tangent. So we will have that tangent, and this force F is going to act along this green tangent line. So let me represent that force F. This is that force F which we need to determine, and this force F is the tangential force. It is acting along this tangent. So now, as we know that the angle between the tangent and the radial direction is always that psi angle, and similarly we need to determine the normal force N. So the normal force is going to be perpendicular with the tangent. So let's say that this horizontal rod is applying the force on this collar in this direction. Let me draw that here. So this is that N force which this rod is applying on this collar. So now as we can see that this N is perpendicular with the tangent, and this theta is perpendicular with the radial axis. So if the angle between the tangent and the radial axis is psi, then this angle is also psi. So now we can find this psi angle, as we know that tan psi is always equal to r divided by dr by d theta. And if we take tan inverse, then we will be able to find that psi angle. So we are given r, so r is, I can write that r is e to the power theta, and the derivative of r with respect to theta will be equal to e to the power theta as well. So now if I divide, let me write that this will be tan inverse, and r is e to the power theta, and dr by d theta is e to the power theta as well. So this will give us tan inverse 1. So tan inverse 1 will give us 45 degrees. So this psi equals to 45 degrees, or we can say that this is pi divided by 4 radians. This is in degrees and this is in radians. So now we know that psi angle. So if this psi angle is 45 degrees, if this is 45 degrees, and this normal is perpendicular with the tangent, so this means that this angle is also 45 degrees, right? Or this angle is also 45 degrees, since this is that psi angle. So this is 45 and this is 45. Now we can resolve this N force into its components. It will have two components. One of its components is going to act in this direction. So if this is the angle, then this is the sine component. It will have one component which will be acting in this direction. So this one is the cos component, this one is the sine component. Similarly, that force F will have two components. It will have one component which will be acting in this direction. This one will be the cos component, this one will be F cos of psi, and psi is 45. And similarly, this force F is going to will have one another component like this one. So it will have one component in the positive theta direction, and this one will be the sine component. Now if I apply the equation of motion, if I apply the kinetics, and if I apply the summation of forces along the radial direction equals to MAR. So AR is the acceleration in the positive radial direction. Let's say that my AR is acting in this direction and my acceleration in theta direction is in this direction. This is A theta. So if I apply the summation of forces along R, so as we can see that this sine component, this is n sine of psi. So we have the sine component of n in the negative r direction, so I will write minus n sine of psi, and psi is 45, remember, and this is the cos component of f which is acting in the positive r, so I will write plus f cos of psi, and this will be equal to the mass. So mass is 2 kg, 2 times AR. So now we need to find AR. So we have this equation from the kinematics, so we can find this AR. So from this we need to find r double dot, which is the double derivative of r with respect to time. So for that, as we know that r is equal to e to the power theta, so if I take the derivative of r with respect to time, then this will be e to the power theta and then theta dot. And similarly, if we take one another derivative of r dot, so that will be r double dot with respect to time. So then we have to apply the product rule, so that will be e theta, and the derivative of this will become theta double dot, and then plus theta dot, and the derivative of e theta is e theta and theta dot. So theta dot into theta dot will become square. So now we can find AR from this. So AR is equal to r double dot, and as we know that we are given that theta is equal to 45 degrees and theta dot is 2 radian per second. So theta dot is 2 radian per second, and further it is said that it is moving with a constant angular motion. So this means that if we take the derivative of theta dot with respect to time, so it is not changing, so this will be equal to 0. So from this we can say that this will become 0. So this is theta dot square e theta. So now AR is r double dot, so r double dot is theta dot square e to the power theta minus r, so r is e to the power theta into theta dot square. So these two terms are similar terms, so they will cancel out. So from this we get AR equals to 0. So AR, there is no acceleration in the radial direction. So now if I put AR equals to 0 in this equation, so this side will be equal to 0. So from this we can write that like this, right? So from this I can write that, and this psi is also 45. So now if I divide the whole equation by sine of 45, so sine of 45 and cos of 45 will have same value. So now from that we can write that minus n plus f is equal to 0, or we can say that f is equal to that normal force. And similarly, if we apply the summation of forces along the theta direction equals to mass times a theta. So now as we can see that we have the cos component of n which is acting in the positive theta direction, so I will write plus and n cos of that psi, and similarly this is the sine component of f which is acting in the positive theta direction, so I will write plus f sine of psi, and this is equal to mass, so the mass is again 2 kg and a theta. Now we need to find a theta using this equation. So since theta double dot is 0, so this will become 0 and we will be left with this. So from this we can write that a theta equals to 2 r dot theta dot. So this is 2 and r dot is e theta dot, and we have one another theta dot, so that will become theta dot square. So this is a theta. So a theta is 2 e to the power pi divided by 4, and similarly theta dot is 2. This is given 2 radians. So this will become 2 square. So this is 2 square is 4. 4 into 2 is 8. So this is 8 into e to the power pi divided by 4. So 8 into e to the power pi divided by 4. So this gives me a theta 17.546. So a theta is 17.546 meter per second square, And now if I put that value of a theta in this equation, so we will have it is 17.546, and now we know that f is equal to n. So if we want to find f, so we have to replace this n by f, so n is equal to f. And so cos of psi and sine of this psi angle is 45, and this is also 45. So cos of 45 and sine of 45 values are same, so we can say that we can add up both of these terms. So we can write that this is 2f cos of 45, or we can say that this is 2f sine of 45. Since cos of 45 and sine of 45 have same values, these two will cancel out, and similarly we will be left with f, and that f will be equal to 17.546, or we can say that this f is equal to n is equal to 17.546 divided by cos of 45. From this equation we know that f is equal to n. So this is this answer. I will write that this answer divided by cos of 45. So that F force is equal to 24.81. So that tangential force is equal to 24.81 newtons, and the same normal force is applied by that horizontal rod on this collar. So this is the solution of this particular problem. I hope it will help you in your learning. If it helps in your learning, kindly subscribe my channel and like this video if you people want me to solve such more problems from Hibbeler Dynamics.